dot notation and so that you get the automatically synthesized getter and setter. But you really have no need to advertise it to anyone else who actually interfaces with this code, even though, admittedly, there is no one else in question in this small example. You can create, effectively, a private property by simply declaring it inside of this thing called a class extension. What's a class extension? Well, again, it's just the use of a category that has no name. What's a category? It's kind of a cyclical story here. What does a category allow you to do in Objective-C? We've not really had to use these ourselves. It allows you to extend a class, an existing class. So if you want to add functionality to the NSString class that Apple didn't think to implement, you can do that by redeclaring the NSString interface, but having your own category by, in parentheses, having a name like foo, which represents your addition to that. Those of you comfortable with JavaScript might know that you can do the same in JavaScript by extending a object's prototype, the .prototype property. Yeah?
In this example, it doesn't really make a difference, but if we had multiple view controllers and we make an interface like that, will we be able to do database queries from other view controllers?
Good question. So if you have multiple view controllers, maybe like in Project 2, will you be able to have them talk to one another? So short answer is it depends. And at least in the context of Project 2, which I'll presumptuously assume is of most interest, you have flipside and main view controller. And those two don't really talk to one another directly. Rather, they talk to one another by way of delegation. So recall that the flip side controller gets in a pointer called the delegate to the main side controller. So if your main side controller has these properties declared and the flip side controller has a pointer there too, to a main view controller object, you can certainly invoke properties in that way. So in short, it depends on who you want talking to whom. And frankly, for the limited scope of the project, it's not a bad thing to practice what we originally preached, which is putting properties in header files and not getting into this additional degree of sophistication. But for those of you who really do kind of want to think about like what are every possible design decisions I can make and maybe should make, realize that this is one of the options. All right. All right. So think back to this example here. This is from a couple weeks ago. And this was one of the very first apps we wrote that did a little something more interesting than just printing to NSLog. And it was an ATM whereby I can punch in some numbers and pretend to make various deposits. And recall this was our first discussion of interface builder where we dragged and dropped the blue lines to create IB outlets and IB action linkages between code and the UI. So what kinds of things might I want to test in this application? What kinds of things might go wrong? You submit this as your homework assignment. What might your TF say, doesn't work right?
Maybe you tagged it wrongly.
OK, so maybe you tagged it wrong. So pressing 9 actually displays 3 or something like that. That's reasonable. Right? Does pressing 9 display 9? That's a reasonable question and reasonable something you'd want to test. What else? Yeah?
If you deposit a lot, like more money, like a ton of money in the bank account, whether it still has that balance that you would expect.
OK, good. So if you deposit $50 plus $100, do you actually have 150 in the balance at the bottom of the screen? So that's a reasonable question to ask. So does your deposit method work? Right, what else might go wrong? Yeah?
You say that you deposit $150 on the screen, does it actually deposit $150?
OK, good. So once you start doing multiple key presses like 1, 5, 0, are you actually doing that multiplying by 10 thing we talked about, the sort of grade school math, to actually change what's actually in the label up top so that you actually do deposit 150? So in short, something could go wrong in most any one of the methods that we implemented in this program. Now, what were those methods? Well, let's just take a quick tour back. Here's the app delegate, which is a good place to start the story. And there's really nothing of interest here. This is mostly this is all boilerplate code that I simply cleaned up with some comments. So if I then turn my attention to init with nib name and the view controller in the .m file, well, let's see what's actually in here. I didn't actually override that because it wasn't necessary because all the initialization comes from the nib itself. So what methods did I have? Well, I had a method called clear, which is what gets invoked when the user hits the clear button, assuming my IB outlets were wired, my IB actions were wired correctly. Deposit, which is called when I push deposit. Digit, which is called when I press any one of the 10 digits. Show, which was a little helper method that I wrote. Should auto rotate to interface orientation, which gets called when I rotate the device. View did load, and so forth. So what are the best candidates for testing here? Probably Apple's should auto rotate method is probably correct, assuming if I'm just returning true or false. But really the interesting question is, do the methods that I wrote that other people are going to call correct? right? It's because if those things are incorrect, maybe your problems are in those methods themselves, or maybe in some of your helper routines. So a very common approach is to have unit tests specifically for your public API. That is, methods that something else is going to call. And in the case here, where I actually have a little helper method called show, I could write a test for that and make sure it does actually show what I expect. But really, at the end of the day, especially for large software projects with multiple people, you care about testing especially your public-facing API, because that, after all, is what's going to break first when other people start using your code. So how do we go about testing this stuff? And actually, what else is there? Well, recall that there's also this model. So also related to Project 2, where you're tasked with creating models for high scores and for your gameplay. Well, here's a very simple model whereby I represented the notion of a bank account with really something super simple, a property called balance that's just a long int, an unsigned long int. And it was implemented only with one helper method called init, which initializes the balance to 0. So the upside is very easy to test that. Make sure that the balance is indeed 0 when I create this thing. Downside is the whole account doesn't really do much, but that's fine. Less to test. All right, so how do we go about creating some unit tests? Well, a couple of ways. When you first create an Xcode project, suppose it's a utility application, and I click Next. Besides typing in something like hangman at the top, you can check off at the bottom, use automatic reference counting, which you absolutely should per the spec. And you can also check include unit test, which is going to give me some boilerplate code for actually bootstrapping this process. If you and your partner did not do that, that's fine. You can still retroactively add unit tests to your code. Realize that the quick tutorial for doing so is at this URL here, which is on today's slide. So you can read the various documentation there. If I go ahead and click Next, in the case of hangman here, click Create, what I'll get on the left-hand side, as you yourselves might have already noticed, is not just the typical boilerplate, but you also get this directory here called hangman tests. So Xcode supports two types of tests, what they call application tests and what they call logic tests. Application tests are meant to test, among other things, your application's user interface or anything involving interaction, anything that would actually require that the simulator itself be fired up. Logic tests typically test your models. So per the spec for Project 2, you're officially only expected to write unit tests for your model classes, so that you're really just testing some of your low-level logic. And we'll look at both examples here, but you'll see that it's actually pretty easy even to test effectively the UI by simulating key presses and such, by manually invoking various IB actions, or specifically by calling the methods that should get called when you touch a button. And yet other frameworks exist for actually trying to test even more of the user interface. So we'll see two of these approaches here. So realize that when you check that box, when the template is first, when you're first prompted with the template, you get these things called application tests by default. So this is stuff generally involving your IB outlets and actions and such. If, however, I go to the File menu and do New and then Target, I can actually add some additional unit tests for this. What is a target? So this is not something, actually, if you think back to makefiles, if you did take 50, recall that for many projects you didn't have a makefile, but when we finally introduced makefiles, we sometimes had multiple targets. The one P set where you had, we had a couple P sets where you would, trying to remember, make generate to generate the pseudo-random number generator C program, and then make find, I think was the P set, even I don't really remember. But we had a makefile that had two targets inside of it, and anytime we gave you a makefile, we also had a third target, or second target, called clean. So anytime you typed make clean, what that was doing was looking in the makefile and executing specific commands to do the notion of cleaning. So Xcode has the same idea of targets. You don't see a makefile, you don't see it at the command line. Instead, you see a little drop down, and they're generally called schemes here. If we go up here to the top, almost always this thing only has the defaults. So if I check here, click here, I see hangman, which is my one target, and then I can choose the actual device to simulate things on. But you can create other such targets so that you can run different commands on your code. In this case, tests. So let me go up to New, Targets. Let me, under iOS, choose Other. And then here, Cocoa Touch Unit Testing Bundle. And then click OK. I'll go ahead and name it in the following way. The convention that's generally recommended by Apple is to use the name of the application, which in this case would be Hangman, then say Logic Tests, or Hangman Application Tests, plural. I'll definitely use automatic reference counting still, and now I'll click Finish. and that's it. I just provide a name. And now notice on the left-hand side, I see a couple of things. One, I now have a new folder called Hangman Logic Tests. And down below that, I have an H file and an M file. Over here on the right, notice that I do indeed have new targets. I have my Hangman target, which represents my application, and I have my Hangman logic test, which represents the thing I just created. And this thing represents the result of my having checked the box when I first chose this template that said use add unit tests or whatever the text was. And now if I look under here, notice that I have two different schemes. This is slightly confusing in that we don't see Hangman tests under there, and that's just because how the template is configured. It doesn't give you a distinct scheme up there, so just FYI. So what do I then see? Well, if I look in the H file and the M file, I see this here in the H file, so that's great. There's not all that much to learn, but the framework that I promised existed in most languages, in this case is called CentTest, which is a framework that Apple adopted some years ago to actually make things easier. If you're familiar with CUnit, JUnit, C++ unit, almost all of these frameworks, except for this one, are something unit, where the something is the language's name. And then here in the M file are a bunch of sample methods that we might want to write. So here's how a unit test works in Objective-C and in many languages frameworks. One, there's a method generally called setup that allows you, the programmer, to do any kind of initialization that has to happen. Allocating objects that you want to test, loading a database from which you need data, anything like that. And the teardown method does the opposite. Frees memory if you need to in whatever language you're using, closes database connections, that kind of stuff. Meanwhile, you can write as many other methods as you want, so long as they start with the word test in lowercase, T-E-S-T, and then capital something. So test foo, test bar, test baz. Because later, when I click the run button up here, but first click and hold on it, and change it to the test button, as you can see here, what that will do is automatically run not my program per se, but my tests, and one at a time, it will execute setup and then test foo. Then teardown, then setup, then test bar, then teardown, then setup, then test baz, then teardown. In other words, it's a heuristic. Any method whose name starts with test will get executed, but right before and right after, setup and teardown will get called. So you can sort of create a pristine state of the world in which to actually run your test. So let's actually now use this in the context of this ATM app, which originally had no tests. I did not check the box 2 weeks ago when we first created this. So I want to go in and start adding some unit tests. And let me go ahead and follow that same sequence of options. I'll go to File, New, Target. And then I'm going to choose Other, and then Cocoa Touch Testing Unit, Unit Testing Framework. Then I'm going to call this ATM Logic Tests. And then Finish. And now I get this folder over here of the code I just described. So in terms of the logic tests, you typically here want to test things like your models. So what is the model in question for the ATM application? Just to make sure everyone's on the same page. So the account. So how do I test the account object's correctness? Well, there's really nothing in the H file other than this property. And in the M file, there's this init method. So really, it would be nice to test one or both of those somehow. And what does it mean to test a property? Well, the property, because of @synthesize, really represents two methods, the getter and the setter. Now here too, it's probably pretty safe to assume that Apple is synthesizing correct getters and setters. So the init method is probably the one I should be suspicious about, because I wrote that, and I'm more likely to be wrong when it comes to the code that's been written. So how do we go about doing this? Well, let me go into my ATM logic test.m, and I might need to do some setup here. So if I actually want to do some setup, I could do something like this. Give me a pointer called account, and give me an account object, alloc, and then call init on it. But I'm going to have to do a couple of things here. This has given me, in my setup method, an account object, and a pointer there too. But my next method, let's call it down here. So notice this is called test example, and it literally is meant to be example. Let's change that to test init. And let me go ahead and delete the sample code that's there. How do I go about testing my init method? Well, if my init method is correct, what should be true? Yeah, so my account.balance should be 0. So, and actually, let's be even more explicit here. I really want to test the balance of this account. So hopefully the thing is 0. But how do I access the account now? This is actually not right. I want to say something like if account.balance equals 0, I want to do success, else I want to do